Are you guys ready to learn a little bit more about IBM Watson? Yeah. Awesome. I'm going to pass around this white paper. I'm going to start on both ends. You guys can just take a look. This is basically what I'm going over in today's presentation. I'm going to introduce you today to the concept of cognitive computing. You'll learn about language, context, and a thing called spatial and temporal dimensions. I know that sounds like a mouthful, but it's actually not that complicated. Watson represents a first step into cognitive systems, a new era of computing. Watson builds on the current era of programmatic computing, but differs in significant ways. The combination of three things make Watson a very powerful tool in the world of cognitive systems. First, the ability to read and understand written text, such as books, text, tweets, posts, anything written in natural English language. IBM can read and understand that. Next, the ability to return a list of correct answers to a question based on only relevant evidence. That's important, and that's called hypothesis generation and evaluation. And lastly, IBM Watson learns and gets smarter with each interaction with its users. It polls the users for whether or not the question is relevant and whether it was the right answer, and it learns from that feedback. And this is called dynamic learning. Cognitive systems such as IBM Watson will transform how organizations think, act, and operate in the future. So what is language? Language is the expression of ideas, but it's also incredibly imprecise, but amazingly accurate. And I know that sounds like a contradiction, but I'll explain what I mean by that in just a moment. Because it all boils down to context, what we're talking about. So think about this. Thank you. We have noses that run, right? We all know what that means. And we have feet that smell, right? Both of those things are incredibly imprecise, but they're really accurate because we understand what they mean based on the context. And think about 2 plus 2. We all know what the answer to 2 plus 2 is. 4, right? Unless we're talking about something else. 2 plus 2, the answer to 2 plus 2 might be a sedan. How could it be a sedan? Well, when you're talking about cars, 2 plus 2 could be 2 front seats and 2 back seats. A sedan. That could be the right answer to that question, depending on the context in which it's asked. That's why context is incredibly important when we're talking about cognitive systems. So there's this concept in cognitive systems called shallow natural language processing, and shallow natural language processing emphasizes precision over accuracy, and it's used in a lot of different ways right now, mostly for sentiment analysis in analyzing tweets or Facebook posts, other social media people put out there. They might write something on their Facebook post like, I stopped by the IBM donut store this morning and it was great. And the sentiment that you might interpret from that is that the IBM donut store was great. But if you look a little bit deeper at the rest of the post, it would be, it was great to hear that the new fictional coffee shop is opening up, so I'm not tempted to eat donuts every morning. So you can see the sentiment is completely different, actually, in what this person wrote. And shallow natural language processing wouldn't pick up on that because it's focused only on precision and very small, narrow pieces of it. It's important to understand that there has a role for large analysis of different, in the aggregate, when you're analyzing hundreds of thousands or millions of tweets, but it tends to be a little bit brittle when you're focusing on individual responses, which you would expect from a cognitive system when you're asking a question and you want an answer back. So you really can't use that for a cognitive system. think about the analogy of bricks. When we use bricks to build buildings, they're really great, and we have this very precise number of bricks that it takes to build a very precise building, and that works great for certain kinds of buildings. But when we want to build bigger buildings, or if we want to build buildings in like an earthquake zone, you wouldn't want to use bricks because it tends to be brittle. And the same kind of thing can be said for natural language processing. You don't want to use shallow natural language processing because it would tend to be brittle when you're using it in a cognitive system. Apple Siri is another example of a shallow NLP. And it will give you a very precise answer if you ask it a very precise question. You have to be very precise. You can't just say, I'm hungry for pizza, and it will give you all the pizza places that are open and close by. I mean, it'll give you a list of pizza places that may or may not be close by, or may or may not be open, but it doesn't really have the context or understand that. Again, shallow NLP is important for large data analysis, but not so much for cognitive systems. So what Watson uses is deep natural language processing. And it uses an incredible amount of context and algorithms that are focused on context in order to perform this deep natural language processing. And to go back to the analogy of the bricks, you know, if you use steel and concrete to make buildings, you can make them taller and make them more resistant to earthquakes. So the same kind of thing can be said for cognitive systems. Let's take a question that Watson answered during the Jeopardy challenge in 2011, which I think all of you are familiar with. So the category was Lincoln blogs, and the question read, Treasury SECY period Chase just submitted this to me for the third time. Guess what, pal? This time I'm accepting it. In the context of today's world, just looking at this question, you might think that the right answer is, what is a friend request? Right? He submitted this friend request 3 times, and now I'm finally accepting it. But what Watson was able to do was look at the category, Lincoln blogs, and then parse through the sentence and determine that Treasury SECY really meant Treasury Secretary. And then it connected the dots between Treasury Secretary Chase and Lincoln, and the answer bubbled up as, what is a resignation? Because Treasury Secretary Chase submitted his resignation. And in the context of all of those things together, that was the correct answer. And this starts to touch on this thing of spatial and temporal dimensions, space and time. It's very important when we're talking about context, when and where things occurred. What's the context of that? So this question, in May 1898, Portugal celebrated the 400th anniversary of this explorer's arrival in India. Wow, this has a lot of different depth to it. There's 2 different times listed here, and there's 2 different places. Watson was able to parse this sentence and determine that what we're talking about is something that happened 400 years before 1898, and it wasn't in Portugal, it was in India, and the event was that this Vasco da Gama landed at Kapad Beach in India. Spatial and temporal evaluation was incredibly important in the context and analyzing this question and figuring out what the right answer would be. So these 3 things, NLP, hypothesis generation, and dynamic learning. All 3 of these things come together to help Watson figure out which answer is the right answer. Possible answers are basically bubbled up from in the Watson system, and the best answers are the ones that are given. And it's doing all this analysis based on context along the way to provide the best answer. It may not necessarily be the right answer, but it's the best answer that it knows about. And then feedback. Feedback is recorded from each user as Watson is being used as to whether or not this is the right answer, so that it can learn. It can know that later on, I'm not going to give you the same answer for the same question. There might be a different answer that would be better. So in effect, Watson ends up getting smarter. And to navigate this huge flood of big data that I'm sure all of you have heard so much about, we need a cognitive system to analyze this. We can't use a simple rules-based system because there would be an infinite number of rules of, if this happened, then this could do, this would happen and this would happen. It would be virtually impossible to come up with the number of rules that you would need to have a system like that. And context really matters, and I hope I've illustrated that well enough for you guys to understand that context is super important here, and temporal and spatial constraints really matter. So what's Watson working on now? Watson's working in the medical research field to help with cancer research. It's ingesting millions of documents into its system and answering questions that researchers might have that they may not know the answers to, and Watson's able to parse through that information and provide valuable information. And what's coming up next? Well, the next evolution of cognitive systems really is all about predicting the future. It will learn to sense, learn to perceive, and have foresight. So imagine if you were going to drive to Denver from Fort Collins and you're leaving at 4 o'clock, and you go into Google and you say, how long will it take me to get to Denver? Google says, well, right now, it'll take you an hour, because it doesn't really have the foresight or the insight to know that in 1 hour, traffic is going to be much worse. But if it had all that information based on historical information, it could tell you, oh yeah, if you leave now, it's going to probably take an hour and 20 minutes. That's what I mean by that. And I believe that in the future, all of us will use cognitive systems, and we will all be better off for it. Thank you.